Okay, let's talk about multiplying matrices. A very simple process if you know how to multiply rows by columns. Here's a matrix. It's got 2 rows, it's got 2 columns, so we call that a 2 by 2 matrix. And here's a column. So we're going to multiply this matrix by this column. Now we know from our previous class, and from reinforcement with the quiz at the beginning of this one, you can multiply a row by a column. You can't multiply a column by a row. Okay, you can't reverse the process. You can only do a row on the left times a column on the right. So what can we do here? Well, somebody in class came right up with a statement. You've got 2 rows. You can multiply either row by this column. Well, since you've got 2 rows and either one could be multiplied by the column, we'll multiply both of the rows by the column. So 3, 5 multiplied by -1, 5 gives you 3 times -1, 5 times 5. And 7 -2 times -1, 5 gives us 7 times -1 minus 2 times 5. And then we do the arithmetic. This comes out 22, this comes out -17. Okay. Now you notice that I took the product of row 1 with this column and put it in row 1 of this matrix. This matrix has 2 rows. The rows are very short, they only have 1 element in them, but they're rows. So this row came from the first row times the column. This came from the second row times the column, and notice it's in the second row of the column. Okay? So, simple procedure, but you've got to practice it a little bit to get used to it. And now I'm looking for my, maybe I have it up here, let's see. Yeah, there it is. Okay. Now, similar matrix, actually it's the same matrix that we just did. And the first column is the same as the one we just got. But then I've got 2 more columns. So there are more ways to multiply rows by columns. I've got 2 rows and I've got 3 columns. So there's 6 possible multiplications. First row times first column, first row times second column, first row times third column, second row times first column, second row times second column, second row times third column. And I'm going to do all those multiplications. Now, when I do the first row by the first column, I get 22. We already saw that because this column is the same as before. The column we used before, and this matrix is the same as the matrix we used before. So, this row times this column gives us 22. Second row times second column gives us -17. We put the result of the first row in the first row. We put the multiple of the second row in the second row. We also put any result we get from the first column in the first column. So both of these numbers go in the first column. Now we're going to multiply the row and column by the second, or I'm going to multiply both rows, each row, by the second column. And those results are going to go into the second column of this matrix. So that 3 times 7, I'm not sure what I did here, but I didn't write it out correctly. The second was correct. It should be 3 times 7 and 5 times -6. So if you're really paying attention to what I did, you realize I don't know what I was looking at or thinking when I wrote this down. I think the rest of them were right. But anyhow, okay, 3 times 7, 5 times -6. Okay, that's from the first row, second column, so it goes in the first row and the second column of our product matrix. Then second row times the second column, 7 times 7, -2 times -6. Goes in the second row and the second column. Then we multiply the first row by the third column, and that result goes in the first row and the third column. And we multiply the second row by the third column, and the result goes into the second row and the third column. Then we can complete the arithmetic. Watch me mess this up. Okay, 21 and negative 30 is negative 9, 49 and 12 is 61, 15 and 15, boy, that's a tough one, that's 30. 35 minus 6 is 29. Okay? Now, this number here came from the second row and the third column. So it's in the second row in the third column. So it should have come from the second row and the third column. If I do the second row times the third column, 7 times 5, yep. Negative 2 times 3, yep. Gives us the 29. Okay, that's how you multiply matrices. Doesn't matter how big the matrices are. The only thing is, the columns have to match up with the rows. In other words, if you've got 2 numbers in the row, you'd better have 2 numbers in your column, or you can't multiply, because as we've seen, if a row and a column have one, if the row or the column has more numbers than the other, you can't match them all up, and you can't do the multiplication. Well, that's matrix multiplication. That's all there is to it. But of course, there are many things that we can do with matrix multiplication. So the first thing you need to do, well, what? In our first class, we learned to multiply rows by columns and add multiples of rows to other rows and do multiples of rows. That's fairly straightforward. And now we're taking our skill in adding multiples of rows and columns to achieve different objectives to reduce matrices. In the process, solving simultaneous linear equations. And we use our skill of multiplying a row by a column, which we've mastered by today, ideally, and hopefully we did, because you need to do that every day so that you don't get lost. And I mean, you can still get lost, but you almost certainly will get lost if we talk about something that you're supposed to have mastered that you haven't. In any case, your skill in multiplying rows by columns leads directly into multiplying matrices, and the entire process is relatively accessible. It's not particularly difficult. You just have to practice a little bit to get used to it.